Greetings, and thank you for joining us today. My name is Hunter Francis, and I'm speaking to you from the Central Coast of California at Cal Poly State University in San Luis Obispo, where I direct the Center for Sustainability in the College of Agriculture, Food, and Environmental Sciences. I'd like to welcome you to our Soil Health Dimensions series. This project came about as a kind of culmination for many programs that we've been offering in recent years related to soil health, composting, and sustainable production systems. Through those, we've accumulated a wealth of information that can be very useful to people involved in production, agriculture, and we're excited to share with you some of what we've learned. This series is essentially for anybody who grows things, producers both large and small, conventional and organic. It provides a comprehensive yet concise overview of some of the things that people are thinking about in approaching soil health, with a particular focus on the soil biology and organic matter in achieving it. On the web page where you found this link, you'll notice there are a number of resources and organizations listed that relate to content covered in each of the 6 modules. At certain times, I'll be pointing these out. In the future, we plan to make this series available through our continuing education department, and this will enable people to watch the series and for a fee enroll to take an exam, which if successfully completed will entitle participants to continuing ed credit. We expect that option will be available in spring 2019, and we'll be letting people know about it when enrollment opens. If interested, keep an eye out for that and/or feel free to sign up for announcements through our website. The series has been broken into 6 parts. We're going to be beginning today with the foundations of soil health, which provides an overview of basic concepts and some of the trends in the soil health movement. The next 2 chapters on soil biology and organic matter will likewise be providing some general background on how the soil biome functions. The series will get progressively more detailed as we move into subsequent chapters on nutrient cycling, management, and assessment. Each segment is fairly standalone, so depending on your expertise, you may wish to just view parts of the series, cut into information that's of interest to you directly, or you can watch the whole thing in entirety, of course. Our ultimate goal is to help people provide better management and stewardship of their soils, thus improving the vitality of their ag systems and ultimately their bottom line. Healthy soils support many vital functions, and when working to their potential can be very helpful in reducing input costs and even time and labor. More and more we're hearing from farmers that investing in one's soils, in fact, can go a surprisingly long way in helping to increase on-farm profitability and long-term productivity. Original funding for this series came from the Western SARE program. SARE is a national USDA program broken into 4 regions across the country that provides both producers and professionals with funding to support projects that increase sustainability both on-farm and in the realm of research and education. With over 30 years of supporting farmers, ranchers, and ag professionals of all sorts, they have accumulated an array of some super helpful and user-friendly resources that are available to the general public and that can be found on their website listed here or on the national SARE.org site. So, as a start, I'd like to give a shout out to Western SARE and a special thank you to them and many of the private funders who've made this series possible. As in virtually all areas of life, new technologies are rapidly being developed to assist agriculture and all those who manage the soil from the landscape level right down to the molecular level. These 2 photos here depict remote sensing and imaging graphics that are picking up variations in the field on the left and biological activity in a soil pore space on the right. This type of precision and other new windows, so to speak, are helping us to understand soil processes in a much more precise and comprehensive way. This is actually a very exciting time to be studying soils because of such advances. It's also exciting because we're realizing more and more how soils function at the nexus of many natural cycles that help us in achieving the quality of life that we all value. Soils are a natural substrate for helping us to produce food, fiber, fuel, and medicines, but they also provide nutrients, habitat, building materials, help regulate the hydrological cycle, help recycle waste, and even clean up toxins through bioremediation. Today, more and more attention is also being given to the important role soils play in sequestering carbon, as we will see. All of these functions provide actual services that have monetary value. By nurturing the soil, and in particular the biological organisms within it, everybody wins, from the farmer to land managers to society at large. So much so, in fact, that soils are now receiving much wider public attention, which is resulting in new initiatives and incentive programs designed to help producers implement improved practices. Here in California, our Department of Agriculture's Healthy Soils program supports a whole host of soil building practices through payments made to farmers to implement them. Other states are now increasingly following suit with similar programs. Of course, the understanding of soils has changed over time. Many may not know this, but soil science as a discipline in and of itself has only been with us for a little over a century. I have here a picture of Eugene Hilgard, who's often considered one of the founders of the science, especially in this country. His pioneering work, Soils and Their Formation, was published in 1901 and was one of the first comprehensive textbooks on soils. Hilgard had quite a legacy, and one of the things that's interesting about him is that he started out as a geologist in the southeastern portion of the country, who was very disturbed by soil degradation that he had witnessed in that region after only 200 years of cultivation. He bemoaned the fact that we had not done a very good job in managing what he called the park-like settings that we had inherited. So even as early as the beginning of the 20th century, there were champions of soil protection and stewardship. The idea of protecting soils is not a new thing, although Hilgard was a geologist by training, and a lot of his focus was on that aspect of soils. Interestingly, our Russian counterparts at the time were taking more of an interest in the biology of soil, although the expansion of industry at that time shifted the focus globally to chemistry for most of the 20th century. One of the hard lessons about what happens when soils are overworked came in the mid-1930s during the infamous Dust Bowl. I like to show this slide when talking about the history of soil conservation. It depicts a day in March 1935 when a dust storm that originated in Kansas made it all the way to the nation's capital. Ironically, and perhaps fatefully, that storm arrived just a few days before Hugh Bennett testified in front of Congress to lobby for permanent funding for the soil erosion service that he led. That later became the Soil Conservation Service, and then after that, the NRCS, or Natural Resources Conservation Service. This was all definitely a wake-up call for the country, and we learned that the fence row to fence row practices that resulted in excessive cultivation with no measures to keep soil in place resulted in horrific erosion when the winds kicked up. What we didn't fully appreciate then but know now is that practices in those days severely compromised the biology of the soil, which is also helpful in keeping soil in place and through helping to provide soil structure. It does this very effectively by encasing soil particles with glues and membranes. This is a picture of Ray Archuleta, a retired NRCS resource specialist who's traveling the country these days doing lectures on the importance of keeping soils alive and healthy. You can often find him performing what's called a slaking test. He's pictured here with two soils, one that has good structure on the right and whose aggregates are holding together well when exposed to water, and another on the left that's not faring as well. There's a link below on this chapter's resource page that shows a demo of Ray's test. Even for those who get the value of well-structured soil, it's really an eye-opener. Another great visualization that I recently saw demonstrated on the role of soils in holding water was this one done by Dee Dee Pershaus, who's been lecturing globally on what she calls the living soil sponge, or the soil carbon sponge. It demonstrates in these two examples how the arrangement of flour particles in bread has a structure that could be seen as analogous to soil with good structure, and when drenched with water does quite a good job of holding that in place as compared to the flour on the left with no structure that allows the water to run off in an eroded mess. It's a pretty good visual, I think. The lesson here that has implications for farmers needing water for crops is that soils in healthy condition and with good structure are actually sponges for water. And when that water infiltrates and percolates down into the soil profile, it means more water for agriculture. This simple graph here shows in the light blue at the bottom what would be lost if water at a certain intensity of rainfall is not captured by the soil. On the other hand, if it is captured, it can double what has been harvested, resulting in a much larger quote-unquote effective rainfall. It's important to note that soils not only help improve quantity of water, but also the quality. The more water penetrates soil and the longer its residence time percolating through it, the longer it's exposed to the myriad microbial processes in the system. And these processes help clean up the water and purify the water molecules that are going through it. Another thing that soil helps capture or sponge up, and that we'll be talking more about in Chapter 3, is carbon. Plants, of course, use carbon brought in as carbon dioxide to produce carbohydrates and other essential building blocks of life. But as we are appreciating more and more, a lot of that carbon winds up in the soil, helping to build organic matter, often in a very significant way. This is a big part of what's driving the resurgence of interest in soils publicly. There's a growing and justifiable movement to get misplaced carbon out of the atmosphere, and the fact that soil is a viable reservoir for it means that a lot of attention is turning to agriculture as a potential vehicle and ally in helping to capture that potential. Practices that build soil have yet another benefit in agricultural systems, and that is that those practices tend to discourage the growth of weeds, one of the banes of agriculture. Keeping soil supplied with a balanced diet, working to maintain good soil structure, tilth, keeping soil covered, and implementing rotations wherever possible can help disrupt the natural cycles of weeds and outcompete them. Appropriate balanced nutrition plays a role because many weeds tend to thrive when nutrients are out of balance, either in terms of excess or deficiency of nutrients. So how do we define soil health? The NRCS, which has over 70 years' experience in promoting soil quality, has recently put out a new definition that says, healthy soil is the continued capacity of soil to function as a vital living ecosystem that sustains plants, animals, and humans. I think that updated definition is really quite interesting in comparison to an older definition, because it really brings out the idea that soil is a living system. A big focus in the past in soil preservation and conservation has been on the physical properties of soil, such as bulk density, penetrability, aggregation, and so forth. But more and more the scientific community is understanding the vital role that biology has to play. The word health itself has an interesting etymology or origin. It's said to have come from the Old English word hal, which relates to wholeness. It also seems to relate to breath, as in inhalation or exhalation. Living things breathe, and soils breathe in a big way. In fact, soil respiration is a technique that's growing in popularity for doing quick measurements as to the status of one's soil health. It's also interesting to note this relationship between breathing and wholeness and health, in that living things have the capacity to heal. I was struck by that comment recently when I heard Joel Salatin of pasture-fed animal fame, that living things have the capacity to heal, unlike inanimate living objects. If your carburetor breaks, it's not going to heal itself, but your soil can. That's an interesting observation and one that should give us hope. Even if soils have been compromised or are unhealthy, we have an opportunity to resuscitate them through better management. That's really great news, and with the right management, soil can sometimes be improved quite rapidly. This slide is somewhat of an aside, has personal meaning to me. I happened to come across it in a library when I was taking some basic courses in biology and chemistry, and that ultimately led me to study soil science at Cal Poly. It turns out it's one of the landmark books of the alternative ag movement. It was written by Lady Eve Balfour in 1940. She went on to found the Soil Association of Great Britain and started the world's first and longest-running trial comparing organic ag to conventional production systems. It's clear in this book that she had a pretty sophisticated understanding of the importance of soil microbiology for her time. And in fact, she was good friends with some of the leading soil microbiologists of her day, notably Selman Waksman, who isolated the first antibiotic from soil in the mid-1930s. Another big portion of the book is dedicated to the relationship between soil health and plant health leading to animal and human health. Like many researchers of her day interested in soil quality, they were very intent on studying traditional cultures around the world, and in fact found that there seemed to be a relationship between the quality of soil management practices and human health and longevity, not to mention food quality. I think that this is worth mentioning because it does have the potential to create economic opportunity for those who care to seize it. In today's global food movement, more and more people are appreciating quality in food in terms of taste, flavor, and nutritional content, and they're often willing to pay for it. The science around food nutritional quality in relationship to agricultural practices is evolving and to date not often conclusive, but scientific evidence does seem to be mounting that there is in fact a connection between good, healthy, nutrient-laden soils and the quality of produce that comes out of it. This includes plant health and end product shelf life, both which have economic consequences. So when one thinks about agriculture from a business or a return on investment perspective, one should also think about what the trends in society are. A lot of growers are starting to pay attention to this relationship because they see it as a way of staying ahead of the curve. Another interesting perspective coming out of the alternative camp, but that is gaining traction in the emerging field of ecological design, is an idea of biomimicry as conceived by Janine Benyus. Ecological design can be applied to virtually any field as a way of developing technologies that are more productive and efficient. The bottom line here is that we have a lot to learn from nature, and in the management of our agricultural and environmental systems, we can benefit from those lessons, including economically. Whenever there's an opportunity to use a biological solution before a technological one, there's often the opportunity to save some money. If we can arrange things such that nature is doing the work for us, we're essentially harnessing it for our potential benefit. In terms of the soil, that means that we should really try to harness the incredible power of the soil microbiome. This graphic was taken from a Bacterial Wars video game. I realize he looks a little mean. I guess part of the lesson here is that these guys have a certain power, and they can do either harm or good. They're no doubt down there, so it's probably a good idea to keep them on our good side. When we do, and when systems underground are working more productively, that translates into more productivity above ground, which in the case of grazing animal means more forage and ultimately more meat. This image depicts a study that was done in the Serengeti comparing the productivity of two grasslands, one having a healthy soil biology and the other to the right with an impaired biology. It's important to remember that what's possible in terms of harnessing a soil's capacity is going to depend on the inherent capacity of the soil where one finds oneself. This is a map of the soil orders in the United States. There are essentially a dozen great soil groupings that are called soil orders by soil scientists. In this country, we were blessed with a lot of that nice green in the middle of the country, our mollisols, and then the lighter green alpha sols, which are slightly more acidic. These soils are some of the most productive soils on the planet, rich in organic matter and great for growing crops. In assessing your own soils, a great place to start is by checking out your own soil type, which includes the overarching order, and that can be done on the link below on this web page. The U.S. Geological Society has surveys now for pretty much the entire country, and those surveys can tell you a lot about your inherent soil qualities and characteristics. More currently, there are a number of new initiatives nationwide that have been launched to help people get a handle on how they rate in terms of their soil health. Usually, these frameworks include a suite of metrics or tests that are seen as being fundamental to soil function. These are a few of the prominent ones that we will be looking at. Links to them can be found on our webpage here. The NRCS has launched a new soil health division that builds upon the many decades of resources and information accumulated to help people understand soil quality. Some of the traditional resources are listed, such as the Soil Quality Test Kit. They also have a number of fact sheets that are very helpful in understanding the different tests, some of them quite new and that are used in the many frameworks that we're talking about here. By and large, some of the indicators that are now being seen as most important are shown here. This list was compiled by the NRCS in talking about what constitutes good parameters for understanding soil health. It's interesting again to note that at least 4 of the 6 here are pretty directly related to soil biology. The recognition is that we want to make sure the soil biome is active, well-fed, diverse, and able to produce some of the nutrients that are needed in agriculture naturally. One of the most recognized soil health assessment frameworks today was put together by Cornell University. They now have run thousands of samples from around the country through it and seem to be coming up with a good understanding of how certain fundamental metrics relate to soil health, especially in soils from the eastern part of the country. On the right, you can see some of the tests that are included in their scorecards, such as organic matter, soil respiration, active carbon, and some of the more traditional metrics like water holding capacity, aggregate stability, and pH. Another exciting initiative that's happening in our country is being put together by the relatively new Soil Health Institute. They likewise are engaging soil scientists from across the country to come up with a comprehensive soil evaluation system that can be used in assessing soil health. They host a number of very informative and well put together resources on their website. One of the leaders in the realm of soil respiration, which we will be talking about in Chapter 6, is Woods End Laboratory of Maine, run by Will Brinton. Dr. Brinton came up with the Solvita soil respiration test, and now the SLAN test, which is the Solvita labile amino nitrogen test. He did a comparison of his own and 2 other soil scoring systems, and although they focus on different parameters or use different tests, there does seem to be a correlation of what they're finding. This is a relatively new field and will take some time for any of these systems to be refined, but it seems that we're increasingly able to use our knowledge of soil health to test and to rate overall health. In the end, it's going to be something that's always difficult to do. I sometimes say I think it's as easy as telling whether one human being is healthier than another. In comparing a human being, we may have different standards when we compare an 80-year-old person to a young athlete in terms of what constitutes health. And this is somewhat comparable in the realm of soils. A sandy southwestern desert soil is going to have different advantages and weaknesses as compared to a temperate northeastern loam. Climate and soil type have a huge impact in terms of what's possible, and that's something we need to keep in mind for any assessment. In spite of the complexities of interpretation of different tests, variability among regions, and so forth, Having a sense for the soil does not need to be rocket science, however. Improvement in health is almost always tangible, and it manifests in some of these easily observable traits in any soil, such as soil structure improving, tilth getting better, soil biology being more active, better, more sweet-smelling soil, not foul, and the fact that soils probably be draining better than they previously might have. When things are working, and soils are also cycling nutrients, kind of pumping them out, if you will, in a much stronger way, there are some fun but illustrative techniques that growers have come up with that are pretty low tech. This is the renowned underwear test that compares the degradation of men's briefs in different soils. In this case, they were looking at the effect of cover crops on soil microbial activity, and what seems to be evident is the fact that yes, the soil using cover crops has a more active biology and did a much better of chewing up the cotton here on the left. We're not going to be talking too much about the practices that bring about soil health in this series, although we will be doing a segment briefly on it in a later expansion of the series. But in a certain sense, that there's not a huge need for it, as there are many organizations around the country, and NRCS in particular, that have done a great job in providing detailed information on useful practices for soil biology and health. The essential four that have been enumerated by NRCS and that are widely accepted as important are trying to maximize the cover on the soils, keeping things planted in it, minimizing the disturbance of it, either physically through tillage or through harsh chemicals that impair biology, and wherever possible, keeping things growing in it diverse, namely through rotations and sometimes where possible through the implementation of livestock, such as in grazing down alley crops in orchards and so on. In the end, building soil health requires a few basic steps. First, we want to know where we're starting. What's our baseline, our constraints, and what opportunities do we have given our soil type and our climate? Ideally, we should manage our land as a living system, try to build the biology, and then monitor, test and see if practices that we're implementing are working out. And remember, one can start small. This has been the case with many farmers that we've talked to. You can just take a small percentage of an overall acreage and try something out, whether it's a biological amendment or slightly modified tillage practice. See if it has some of those basic soil qualities come back and how they can help with your bottom line. In the end, I think the soil health discussion is interesting because it seems to be indicative of a pretty profound change in the way we look at things that's affecting not just agriculture but all of society. All this focus on biology is creating a new appreciation for soils and really a new paradigm. The day of the silver bullet seems to be fading. What we're realizing now more and more is that getting to health is about relationship. And trust me, as someone in education surrounded by millennials, the new paradigm is becoming all about networking and connection. And maybe young people are onto something because that's how living systems work. When we confront a problem, it may seem effective just to knock it out, and in some cases it is effective. Let's face it, in dealing with living systems, whether it's a mealybug on a vine or a rash on our skin, sometimes we have a remedy that we need to implement to get the situation under control. But the point is that any action taken in a living system can have ripple effects, and those can be for either the good or the bad. So in tweaking the system, we should not only think about the problem or solution at hand, but how we're affecting all the other pieces of the puzzle, including the biology. That's what's called thinking holistically, with the big picture in mind. Thanks for joining us. We hope to see you in Chapter 2.